Hi everyone. We're going to practice some problems. So there's quite a few of these problems if you're in my class on your homework as well as your exam. So I just want to go through kind of three different ways that we could be asked and actually sort of put these in order. They're sort of hardest to easier. So we're actually going to start with C and then do B and then do A. And we're going to fill in this table. Okay, and so the first thing I want to do is just write out what we already know, and those are our equations. In the previous video we learned that pH is equal to the negative log of the hydronium concentration, and we also know that Kw, the ion product constant, relates hydroxide concentration and hydronium concentration, and experimentally we know that this is always the concentration that we get for both of these. We have equal concentrations of these in a neutral solution. Okay, and so we're going to use these together sometimes or however we work them out, but we're going to first start with C. So if I'm given the hydronium concentration and I want to find pH, all I have to do is take the negative log of it. Alright, so if I take the negative log in my calculator, negative log of, and then I usually put in parenthesis, okay, so I would plug that in right here, negative log of 2.50 times 10 to the negative 6. I'm going to check my work just to make sure, give you time to punch it in your calculator. I get a pH of 5.60. This makes sense. A pH less than 7 means that it is acidic, and it makes sense because we have a larger number than times 10 to the negative 7, right? So we have a larger hydronium concentration, which would make it more acidic. The second place that we have to fill in is we know if we are given hydronium concentration, we can always solve for hydroxide, and by using Kw. Okay, and so if we rearrange our equation here, we get Kw divided by hydronium concentration, which was 2.50 times 10 to the negative 6, and that was here. And that will give us hydroxide concentration. So we did problems like these in a previous video, and you just divide Kw by the concentration that you know. And if you do that, you get 4.0 times 10 to the negative 9. All right. B. So this one involves the antilog. Okay, we're still using this equation, but we're rearranging it. So we have the pH, we're given this, and we need to find hydronium concentration. So in your calculator, when you rearrange this, in your calculator, you should do the antilog. So in mine, I push second function log, and that gives me the antilog. That's how it shows up. And then I put negative whatever the pH is, 12.61. Okay? Still using that equation, but when we rearrange it, we have a negative, so don't forget that here. Okay? We have to push second function log. So this is the antilog, and then we put in negative and whatever the pH is that we're given. And so when we do that, our answer should be 2.45 times 10 to the negative 13. Okay. 2.45 times 10 to the negative 13. I'm going to check my answer one more time just to make sure while you're plugging yours in. And that seems correct. Okay, so we can fill in the hydroxide concentration just like we did here. So we take our 1.0 times 10 to the negative 14. That's our Kw, our constant. And we divide it by the hydronium concentration that we just found. Okay. And we get about 4.08 times 10 to the negative 2 molarity. And your calculator may have just shown up as 0.0408. That's the same thing, right? This is just in scientific notation. Okay, if you are getting incorrect answers, but you understand the equations and you understand what's being plugged in, then you're having a calculator issue. Okay, and so we need to try to figure out what's happening. Be sure that you're putting everything in parentheses if you're having that issue. That often will solve the problem. Okay, and then A. So this time we want to look for pH and hydronium concentration, and we're given hydroxide concentration. So for this one, we still start here with Kw, but we have to find hydronium concentration. So we take our Kw, divide by hydroxide concentration. And that will give us hydronium concentration. So I'm just taking this and rearranging it to solve for hydronium concentration. And we should get 4.0 times 10 to the negative 9. Okay, and like I said, please check your answers, use your calculators, okay, and use the same calculator when you take the tests and do the homework. Okay, if you forget it and have to use a different calculator, it can work differently. Okay, and so that should give us and oops, I'm glad I used the number from earlier. Glad I checked my answer here. Let me erase. So hopefully you caught this and you're going, oh, that doesn't look right. All right, so if you divide and do this, that's not what you get. That was my answer for C that I copied down wrong. So you get 1.51 times 10 to the negative 10. Okay. Hopefully you caught that. I was just checking. Just kidding. Okay. So now we have our hydronium concentration. So to find the pH, we just take the negative log. So we put negative log of 1.51 times 10 to the negative 10. So negative log of 1.51 times 10 to the negative 10 should get you should get about 9.82. Alright, so just a few different variations here using your KW. Okay, these are two formulas that you must know for this portion of the course. Okay, and then beyond that, you just have to plug in those numbers, rearrange the equations in just a few different ways that you might see these problems. Alright, I hope this helps, and I will see you again.